If you follow along with me, I can assure you that you will be having a solid understanding of aerodynamics, the basics of engineering, and rocket science. Welcome to Aerodynamics in Minutes. In this video, we are going to understand what is Y plus value in CFD. To understand Y plus, first we need to know about the boundary layer. In physics and fluid mechanics, a boundary layer is a layer of fluid near a bounding surface where the effect of viscosity are significant, and there will be a presence of velocity gradient. The boundary layer thickness is denoted by the symbol delta. In CFD, we solve the fluid domain by disintegrating the whole fluid domain into small volumes of fluid. In that small volume, we apply continuity, energy, and momentum equations and solve for the unknowns. Y plus. What is Y plus? Y plus provides a relation between friction velocity, absolute distance from the wall to the center of the cell, and kinematic viscosity. The formula for Y plus is the distance from the wall into frictional velocity divided by the kinematic viscosity, and it doesn't have any units. Think Y plus similar to Reynolds number. Reynolds number has no unit but tells the fluid turbulence property. Similarly, Y plus is a check from the user's side as a guideline for good saved result. And the equation can be rewritten as shown, where mu is dynamic viscosity. What is the Y plus value I need for an accurate solution? And what is the corresponding YP value to set my fluid volume size or mesh? To answer these questions, let us see the Y plus experimental data. This black curve is the experimental data, Y plus versus U plus, a dimensionless velocity. This dimensionless velocity is given by free stream velocity divided by friction velocity. CFD solvers model this Y plus curve as two separate empirical equations, shown in the blue curve in the post-processing. Solvers will not use any of these Y plus equations to solve the near wall, but Y plus, as I said earlier, Y plus is a check from the user's side as the guidelines for good CFD results. If the Y plus value lies below 5, the solver in the post-process uses viscous sublayer equation. If the Y plus lies between 30 and 200, the solver uses log-law empirical equations. And the Y plus value that we need to maintain for good CFD results from our side is below 5, which will enable the solver to solve the near wall properties properly. Now we will see how to find the YP value, that is the absolute distance from the wall to the center of the cell. Note that twice the YP is our first cell size. In the Y plus equation, the only term that we don't know is UT, and UP is equal to root of wall shear stress divided by dynamic viscosity. And wall shear stress is a result of CFD, so for approximate Y plus value to start with, we take the values of flat plate. The wall shear stress of a flat plate is given by the formula half rho velocity square into skin friction coefficient. The empirical relation of skin friction coefficient of a flat plate is shown. Substitute Reynolds number in this equation, then from this friction coefficient we can find wall shear stress. From wall shear stress we can find frictional velocity. Now we know all the unknowns of the Y plus equations to find YP. Substitute the target Y plus in this equation. We will get YP to set our first cell or mesh height. For more accurate solution, we need to maintain a Y plus value below or equal to 1. The CFD solution diverges. Try increasing the Y plus value and run it again. Now, from the CFD result, find the Y plus value in the post-processing. And now, if the Y plus value from the CFD result is smaller than the actual one, refine the mesh to have the same Y plus and run it again. And again, check the CFD Y plus and actual Y plus, adjust them and rerun it. I refer Fluid Mechanics 101 channel for making content for this video, and he made a calculator for solving YP value. Go to his website, click the calculator on the top bar, then you will be redirected to this web page. Click inflation layer, then you will be navigated to the inflation layer calculator. Enter the input fields as, then it will calculate and tell the height of first and last layer and growth rate too. Anyway, thank you for watching. This is Dhyani signing up in Aerodynamics in minutes. See you in the next video. Stay tuned.